Hello everyone! What we're going to do today is the lesson. This is it. It is multiplication and dividing fractions word, I said that word. Multiplying and dividing fraction word problems. There it is. So what I'm going to do is I'm going to show you two different kinds of multiplication word problems, show you examples of each, and then I'm going to show you two different kinds of division word problems. Alright? We're going to split it up by multiplication and division, so that way you have a nice guide of what you're looking for when you go into these word problems. Okay? Okay, so for multiplication, that's where we're going to start. We have two types of word problems. Our first type is where we're multiplying by a fraction less than 1. And in these cases, you're going to be asking yourself, can you say some fraction of a total? We're looking for part of the total. If we're multiplying by a fraction less than 1, we have the total. We have the total. And we're looking for part of it. And that's different from a regular multiplication problem. Usually we want to find the total in a regular multiplication problem, but if we're multiplying by a fraction less than 1, we want a part of that total. We already have the total. Our second type is when we're multiplying by a number of fractions greater than 1. And in this case, we are looking for a total. And a key word to keep in mind is each. Same as any other multiplication word problem, each, when it's in the information, is a key word letting you know, hey, flashing lights and sirens, this is a multiplication problem. All right? So let's look at some examples. And our first example is, one second. Much better. Let's look at this example. This is a type 1 problem, multiplying by a fraction less than 1. And it says, of the, I'm just going to stop right there. Look up to that top slide. Can you say blank of the total, or of a total? Whoa. It's like it's already telling you what kind of problem it is. Of the 18 students, 1/6 have red hair. How many of the students have red hair? Well, 18 students is our total. And we're multiplying that by a fraction less than 1. So, before we get into the actual problem, let's draw a picture. We're going to be drawing lots of pictures today just to make sure that we're understanding everything. So, I have my 18 students down here, my 18 student class. 1/6 of them have red hair. So, for one out of every 6, I'm going to give red hair. 1 redheaded student, 2 redheaded students, 3 redheaded students. So 1/6 of 18, 1/6 of 18, is 3. So says my picture. Let's check. 18 students times 1/6 of them having red hair equals 18 over 1 times 1/6 equals 18 over 6 equals 3 students. Make sense? And again, we're looking for part of a total. Our total is 18 students. The part of that total that has red hair is 3 students. All right, moving right along. Let's look at another example of this. Type 1, multiplying by a fraction less than 1. There is 1/4 of the cake left over from the party. Karen wants to eat half of the leftover cake as a midnight snack. How much of the cake does she eat? All right, so we have a total. 1/4 of the cake is the total. And she wants to eat half of it. And that's multiplying by something less than 1. I just wrote greater than 1. What am I doing? greater than 1. And hey, again, we have the words of the. If you see of the, you could definitely say 1/2 of the total, 1/2 of the 1/4 left over. Let's look at our picture down here. So I have my leftover cake. The yellow part is my 1/4 leftover, and I drew this red, and now green, line showing that she's going to eat 1/2. So she's going to eat that part. Now what part of the entire cake does she eat? Because remember, we're looking for a part. We have the total. What part of the cake does she eat? Well, this is now becomes 1/8. Let's find out. My total, 1/4 times 1/2 equals 1/8 of the cake. Funny how that works out, isn't it? All right. There are two problems. You know what? Let's all just do all these together. Another type 1. Ethan went to physical education class 72 times this year. He spent 3/4 of the classes outside. How many classes this year were held outside? So for this one, there is no picture because no one wants to draw 72 things to represent the 72 times. But we know that we have 72 times. That's the total. We have a total. Again, 3/4 of the classes were outside. And again, we're multiplying by a fraction less than 1. So 72 times 3/4 equals 72 over 1 times 3/4 equals 216/4 equals 54 classes. 54 classes were outside. And look, this makes sense because this is part of the total. All right. For our last type 1 problem, Francesca and her cups of flour. I want you to do this on your own. Fill out the picture. You have to fill out that picture and find your answer. All right? Francesca had 32 cups of flour. She used 3/8 of the flour for a recipe. How much flour did Francesca use? Solve this problem. Fill out your picture. Come back with an answer. 3, 2, 1. Pause. All right, we can tell that this is a multiplying problem because we're looking for a part of the total. 32 cups of flour. She used 3/8 of them. So in my picture, what I did was for every 8 cups of flour, I shaded it in 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's see, moving over to my algorithm, do I get 12 cups? I do. 32 over 1 times 3/8 equals 96 over 8. 8 goes into 96. 12 times she used 12 cups. And there's just one example for type 2. It's multiplying by a fraction greater than 1. And we're not talking about regular donuts here, unfortunately, but we're talking about baseball donuts. Our weights placed on baseball bats during warm-up. A high school team uses baseball donuts that weigh 5 1/7 ounces each. The team brings 8 baseball donuts to away games. How many ounces travel to away games? How many ounces travel to away games? What are we looking for there? We're looking for a total. We're looking for a total. That's already different than our last problems because we had a total in those. Now we're looking for one. But the key word is here, each. In the information, not in the question. Since that each is in the information, that lets us know, flashing lights and sirens, that this is a multiplication problem. And if you weren't sure still, you could draw a picture. So here I have my 8 baseball donuts down the bottom. Each one weighs 5 1/7 ounces. And you just have to think, hey, I'm looking for how many ounces travel to away games. I have 8 baseball donuts, each is 5 1/7 ounces. I need to multiply by that. My 8 baseball donuts times 5 1/7 ounces each. And that's how I'm going to solve my problem. So 5 1/7 times 8/1, let's just cut to that chase, equals 36/7 times 8/1 equals 288/7. All over the place here. 41 1/7 ounces. And here you can use some reasoning too. Even if you, by some miracle, divided here, 5 1/7 divided by, or 8 divided by 5 1/7, you would have gotten 9/14, not 4 up here. Sorry guys. 9/14 ounces would have been your answer, would have been your quotient. How many ounces travel to away games? 9/14 of an ounce? No, that makes no sense. One baseball donut weighs 5 1/7 ounces. You can't tell me that if you bring 8 of those donuts, they're going to weigh less than 1 ounce? No way. So, be sure that if you get an answer, you look back and say, does that make sense? Does that actually make sense? And try and reason with it. If you can't reason with it, it needs to be the other way. It needs to be a multiplication then.